Hello and welcome back to chemistry. In particular today, what we are going to do is go over the subject of pure substances and mixtures. And the main point of today's lesson is to get you guys to go ahead and categorize different objects to be four different types of things. Okay, and we're going to be working through a kind of flow chart to go ahead and go through it. And the four things that we want to go ahead and categorize are going to be whether something is going to be a compound, an element, a homogeneous mixture, or a heterogeneous mixture. So these are the four things that we want to be able to define any object that we see as. Okay, so what we're going to do is we're going to go ahead and go over how to use this flowchart and kind of be able to take an object that we don't know what it is, use this flowchart to fit it into defined boxes so that we can label it as one of those four different objects. So the very first thing that we're going to do with any type of object, we're going to ask, does it have mass and take up space? Because remember from earlier, if something has mass and takes up space, that makes it matter. So if it has mass and takes up space, then we're going to go ahead and say that it's matter, and we'll go ahead and go into this category right here. And this next category is having us define whether something's a mixture or a pure substance. And there are two different ways that we can go ahead and define a mixture. A mixture can either be something that's easily to physically separate, which means that you can use the different physical properties of things within the mixture to separate it. It can also be anything that does not have a fixed composition, which means that you can go ahead and modify how much of different materials are in there. Whereas a pure substance has a defined composition. So it has to have the exact same amount of things in there. And you can go ahead and think about this sort of like any type of potato or macaroni salad. Every family has a different type of potato or macaroni salad. Some people use mustard in their potato salad. Some people don't use mustard in their potato salad. Just based on the fact that there can be variability means that a potato salad is going to be a mixture. The other thing is, can it be physically separated? So if you can physically pick it out, so if you can identify a color and then take that color out, that's an example of a physical separation. If you are able to spin it around really fast and then take the less dense stuff from the top, sort of like what happens when they take plasma out from when you donate blood, that's an example of a physical separation too. They're using the physical properties that plasma is more dense than the red blood cells in order to separate out the plasma from the blood cells right there. So those are the two kind of defining things to help us think, okay, is it a mixture or a pure substance? Now, if you determine that it cannot be physically separated or that it has a fixed composition, then you can go ahead and go in to the box of pure substances. Once you're in pure substances, you need to ask yourself, hey, can this be chemically separated? Can I do a chemical experiment with it and separate it out into smaller pieces? If you cannot, then that's going to give you no. If you can, that's going to give you yes. And if it's yes, that means that it's going to end up being a compound. And a compound is going to be something that has two or more elements in it. So for instance here we have H2O. And H2O is made up of hydrogen and oxygen. And then it ends up being two different elements that compose it. Below that we have NaCl, which many know as table salt, sodium chloride, and that has two elements in it. NH3 is ammonia, and that has two elements in it. So all of these have at least two elements in them. So all of these could end up being chemically separated. If you pass electricity through H2O, you'll be able to separate it. And this right here ends up showing us, hey, this is a representation. Here, notice that we have the purple dots end up representing hydrogen, and we have an oxygen. So we have two different elements in here, and that's going to be a compound. Ammonia right here, notice this has two different elements. The nitrogen ends up being this orange color, and hydrogen still ends up being the purple dots. Carbon dioxide, that's another common compound that you guys know, ends up having oxygen, and in the middle it has a blue for the carbon. Now, if it cannot be chemically separated, that means that it's going to be an element. And an element just means it's a single type of an element. So all those elements on the periodic table, if they're by themselves, we consider them just in their elemental form. And it doesn't matter if it's 2 of them together or 8 of them together in some special cases. If it's just that element by itself, we call it as that element. Okay, so examples of elements that you guys have heard of are oxygen, sodium is another element, hydrogen is another element, and carbon is another element. Now, of these elements, there are 7 that I want you to take special note of that we're going to be using fairly frequently throughout the year. And these 7 always have a pair. And what you can see here is that oxygen and hydrogen, that we both have that 2 here. And all that it really means is that they always are paired with another one of themselves when they're by themselves. And the 7 that are that way are going to be hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Okay. All of these compounds need to have a partner. Otherwise, they're just too energetic and they're going to bond with something else way too quickly. So these ones always have a partner when they're out in nature by themselves. And I just want you to record that, because when we go through and get later on in this year, every time that I talk about hydrogen gas, you need to be able to, quickly think in your head, oh, hydrogen gas, that's H2. That's 2 atoms of hydrogen. And when I say oxygen gas, oh, that's O2, that's 2 atoms of oxygen together. All right, so those are what's in pure substances. Now we'll have to go ahead and go what's into mixtures. So again, this was, can it be physically separated, and is its composition constant? Or is the composition variable? And mixtures can be variable. So we'll go into mixtures, and the question for mixtures is only going to be, is the composition uniform? Okay? And if it's uniform, that means that it's the same all over. So here, if it's the same all over, then it's going to be a homogeneous mixture. And remember, homo, especially from biology with homozygous gametes, that homo means same. Okay? So that means that it's the same all over. And here I have a brief image of homogenized milk. So this is milk that has been homogenized. And what they do is they really just basically mix it up to an extreme extent so that all the pieces end up being the same, that you don't have the fat coming out on top like you do with regular milk. And so whenever you hear of a homogeneous mixture, you need to just think, oh, that looks the same all over. Okay. The next one is if it is not uniform, that means that it's going to be a heterogeneous mixture. And a heterogeneous mixture is going to look different, so it's going to have different things. So, as a perfect example here, we have Chex Mix. You could see that there's a wide variety of things that are going on here. You have the corn Chex, you have the rice Chex, you have the pretzels and cashews. You have a whole bunch of things that are going on with Chex Mix. All of those things, you could obviously tell that, there's different things involved there. Whereas with the milk, it looks all the same. Okay. Now, there are different things that are in this milk. So, for instance, there's water molecules in this milk. This is a glass of chocolate milk, so there's probably some chocolate syrup in there. There's fat molecules in the milk. There's protein that's in the milk. But you can't take a look and see all those individual things, which is different from the Chex Mix, which you can see that there are different things to it. Okay, and those end up forming the different things that we can classify things as. And now it's gone too far. There we go. Okay. Now, this is what the chart ends up looking like if you have the full chart all at once. And notice that it's the same process that we went over before. In this case, for our second question, it has fixed composition instead of the can it be physically separated. However, this chart is one that I want to make sure that you guys have like the entire chart filled out in your notebook so that you can go ahead and define different pieces of matter later this week. So, to close, what we did was we just figured out the ways to categorize matter and what defines those different things of matter.